In the previous lecture, we have discussed the Cauchy problem for nonlinear partial differential equation, and we have also seen what is the method to do this. Here in this lecture also I'm discussing a couple of more examples for the same. So the first example that I'm considering is find by method of characteristic the integral surface of the nonlinear differential equation, that is PQ is equal to XY, which passes through a given line. So instead of curve, it is given line. Z is equal to X and Y equal to 0. So that is an intersection of these two planes will gives you a line. So first of all, as into this method, Cauchy method, we need to find out what will be the initial streak. And for that, we need to have initial data in a parametric form. This is in Cartesian form is given. So this is the initial data is there. So parametric form of this line. So the initial data curve here is, if I put X is equal to S, then Y is already 0 and Z0 is S. So this is the situation we have. Now we have to check the two equations. That is, this initial data curve is should satisfy two equations. The first one is, so in this case, we should check what is f of x0, y0, z0, p0, q0 equal to 0 and dz0 by ds is equal to p0 dx0 by ds plus q0 dy0 by ds. This is the things we should check. These are the two equations that we need to see whether it is verified or not. Here, what is f of xyz pq is given. So that is this equation, which will be pq minus xy. So as per this one, that means x0 value is s, y0 is 0, z0 is, if I substitute all this value here, this will leads to that p0 of s into q0 of s equal to 0. And this equation will leads to dz0 by ds. That means the derivative of the z0 with respect to s will gives me 1 is equal to p0. dx0 by ds, that is also 1 plus q0, y0 is 0. Derivative of y0 with respect to s is 0. So finally we'll got two equations. The first one is p0 into q0 is 0. And second equation from this one will gives me p0 is 1. Since P0 is 1, this will give me Q0 is also 0. So these are the unique, this is the unique strip we got here. So therefore the unique initial strip is P0 is equal to 1 and Q0 is 0. Now we have to write down what is the characteristic equations. The characteristic equations are, that is dx by dt is equal to fp, but you can see that fp, that is a function. Let me write that function here. So this is our function. F is given pq minus xy equal to 0. So if I can find out fp, that is q, the derivative of this function with respect to p, dy by dt, it is fq, which will be p, dz by dt will be pft plus qfq, that is pq plus pq, and that will gives me 2 pq. dp by dt, dp by dt is fx plus p fz. But you just note that there is no z in this function. So that's why a derivative of this function with respect to z is 0. So only you will have fx. But this is actually of minus sign. So it is of, this is minus of this. So that will gives me minus of minus y. So that's why you will get y. Yes, anyone has raised their hand. So if you have any problem, you can ask. dq by dt is equal to fy plus pfz, but fy is minus x and fz is 0. So that's why this will give me minus of minus x, and which will give me x. So these are the five equations we got. We need to solve them. So just compare the equation with, you just see that dp by dt. So what is, let me write down once more time here. So we'll have dx by dt. Here according to that it is q. dy by dt, it is p. dz by dt, it is 2pq. And dp by dt, it is y. And dq by dt will be x. That is the things we got from here. Now we have to solve this 5 equation. You just compare this one and this one. Let us see what is happening. If I take the derivative again of this function, this differential equation, then this will give me d square x by dt square is equal to dq by dt. And from this, dq by dt is x. So that's why we have d square x by dt square plus x is equal to 0. And this is a second order ordinary differential equation is there. And you know how to find out the second order ordinary differential equation. That means this is d square plus 1 x is equal to 0. So the auxiliary equation is d square plus 1 is 0. So here the value of d, it is minus I. So it is come into the sign. The square should be minus 1. Why it is minus 1? Dx by dt is this. The square is minus 1. So that is I square. So the value of d, it is plus or minus I. Since it is a plus or minus I, your value of x of t, it is a cos t plus b sin t. So this is the value of x we got. This actually x is a function of two variables. X is actually a function of s and t. So this a and b are the function of s that we have here. Same way you will do same situation with this y. If I have this equation and from that if I differentiate that, we can write d square y by dt square is equal to dp by dt. But dp by dt is y. Here I have make a mistake. Na? This goes on the other side, so this will be minus. Why you guys are not telling me? This is minus, this is minus. So this will gives me plus 1. So this is equal to 1. So the value of d will be plus or minus 1. So this things we got, it is a e power t plus b e power minus t. Here we got d square minus 1 y equal to 0. So the auxiliary equation here is d square equal to 1. So that means here is also d equal to plus or minus 1. So the value of y of st is c e power t plus b e power minus t. So this will be the value of x you got, value of y you got. Now we see what will be the value of p and q we'll have. So if you have this equation, I start with this equation now. So now what we'll start with, dp by dt equal to y. So that's why d square p by dt square will be dy by dt. But as per this, dy by dt is p. So this is equal to p. So therefore, you will have equation is d square y by dt square plus p equal to, sorry, minus p equal to 0. In fact, there is no need to do this one. Why? Because we have, so there is also no need of this one. Because I need to find out the value of p, I will use this. That is dy by dt is equal to p. We have dy by dt is equal to p. So therefore, p equal to d by dt of the value of y we already have here. So we'll substitute that c e power t plus d e power minus t. Why I have written here it is d. So that is c e power t minus d e power minus t. So this will be the value of p you will have. Same way, dx by dt is equal to q we have here. Dx by dt is q. We have already value of x we have calculated. That is d by dt of a e power t plus b e power minus t. So the value of q, you will have a e power t minus b e power minus t. The ultimate goal is to find out the value of z in terms of xy. So what is dz by dt we have given? The dz by dt is given 2 times pq. That is this equation we have here. So this is dz by dt is equal to 2 times pq. We'll have now p and q both value. We'll substitute here. We'll have p is c e power t minus d e power minus t into a e power t minus b e power minus t. If you multiply this to brackets, then this will lead to 2 times ac e power 2t. When you multiply this quantity to here, then the constant term you will have, and this quantity when you multiply here, that will be minus minus plus 2 times bd e power minus 2t. Then the constant term you will have, the constant term is minus 2 c bc, minus 2 bc and minus 2 ad. This is dz by dt. From this, if I want to calculate what is the value of z, then I should integrate both sides. So if you integrate this one, then you will have z is equal to ac into e power 2t, because integration of e power 2t is e power 2t upon 2. 2 will get cancelled with from this, plus bd e power minus 2t. So this minus bd will come with the minus sign, because the integration of e power minus 2t is minus in the denominator, minus 2 in the denominator. And then this quantity is there. That is the integration of this one will gives you minus of 2 is already there. bc plus ad into t plus some another constant will appear, that is, let's say it is e. Now we have to use the initial conditions. Using the initial condition, ultimate goal is to calculate what will be this constants. So if I use the initial condition, the initial condition is we have given x0 is s, y0 is 0, z0 is s, p0 we have got, that is 1, and q0 is 0. p0 is 1 and q0 is 0. This is the initial state. Let us use this one. So first we have this x value of x, we have it is a e power t plus b e power minus t. This will implies this is s. This will implies s is equal to a plus b. We have second equation, that is c e power t plus d e power minus t. This was the value of y we have from here. And if I use this initial condition, that is t is 0, y is 0, this will give you c plus d equal to 0. We have z, that is hold this value. And using that value, we can got z0 is s. So I'll not write all the things, but let me write. It has to be right. E raised to 2t minus bd, e raised to minus 2t minus 2 times pc plus ad into t plus e will implies s is equal to ac minus bd. T is 0, so this term is 0 plus e. Then we have p equal to We got the value of p, that is c e power t minus d e power minus t. So we'll have c e power t minus d e power minus t. If I substitute the value of t here, that is 0, and the value of p is 1, so that will gives me 1 is equal to c minus d. And the lastly we have q equal to, that is a e power t minus b e power minus t. If I substitute t equal to 0 here, and q is already 0, so that's why 0 is equal to a minus b. So this will imply a equal to b. Since a equal to b, if I use here that quantity, then it will gives me 2a is equal to s. So that will gives me 2a is equal to s. So that will imply a equal to s by 2, and a and b are same, so b is also s by 2. So the value of a is s by 2, value of b is s by 2. Since c plus d is 0, this will gives me c is equal to minus d. If I use this value of c is equal to minus d here, then the value of 2d we got, and 2d is minus 1, that you can just see, because if I substitute minus 1, 2d is minus 1, and this will gives me d is equal to minus 1 by 2. So the c value of c is 1 by 2, because c is minus d. So the c is 1 by 2. Now since a is this, b and c we all values got. Now last, if you use this one, now we'll substitute this value here. Now using, let me say this is star, using star, you will have AC minus BD plus E is equal to S, we already have. So if I substitute A is equal to S by 2, C is 1 by 2, minus B is S by 2, D is minus 1 by 2, plus E equal to S. So this will gives me S by 4 plus S by 4. So that is S by 2. And so therefore the value of E is S minus S by 2, will be S by 2. So now we'll got all the values of A, all the constants we have. So finally you will have the value of all the expression. That means the value of x, which we have a e raised to t plus b e raised to minus t. As per this a and b is s by 2, so it is s by 2 is common, I can take e power t plus e power minus t, which I can write down e power t plus e power minus t as a hyperbolic function, cos hyperbolic function. So it is s cos hyperbolic of t. The value of y, that we have c e power t plus d e power minus t. But the value of c and d, we have c is 1 by 2, d is minus 1 by 2. So it is 1 by 2 is common, e power t minus e power minus t. So that will be sine hyperbolic of t. We have z. The value of z, it is this AC, A into C. A is S by 2, C is 1 by 2. So it is S by 4 e raised to 2t. S by 4 e raised to 2t. Then it is minus BD. The B is S by 2, D is minus 1 by 2. So it is minus minus plus S by 4 e raised to minus 2t. Then it is minus 2 BC. B is S by 2, C is 1 by 2. So that is minus 2 S by 4 plus AD. A is S by 2 and D is minus 1 by 2. So that will gives me minus s by 4 plus e. The value of e we have s by 2. So this is s by 2. So that will get cancelled out. And this quantity is nothing but the s by 4 e power 2t plus e power minus t plus s by 4, s by 2. And you just see that this is s by 2 is common out, and the left inside is cos hyperbolic of 2t plus 1. This is the value of z. The value of p you will have. The p is this c e power t minus d e power minus t. So the value of p is c e power t minus d e power minus t. The value of c we got it is 1 by 2, d is minus 1 by 2. So this will gives me e power t plus e power minus t by 2. So that will gives me cos hyperbolic of t. And the value of q you will have, it is a e power t minus b e power minus t. A and b both of them are s by 2. So s is common out, e raised to t plus, sorry, minus e raised to minus t by 2. So that is s sine hyperbolic of t. And you just see that now we need to have the expression of, this is in terms of xyz. Ultimate goal is to calculate, it is in terms of xyz. So what to do? So here z is equal to, we have s into cos hyperbolic of 2t plus 1. We have to express this quantity in terms of xy. So for that, we should write down, and we have x is equal to s cos hyperbolic of t and y is equal to sine hyperbolic of t. This is the things we already have here. This quantity we can write in this fashion: s e power 2t plus e power minus 2t upon 2 plus 1. If I take LCM, then this is s by 2 e power 2t plus e power minus 2t plus 2, and this 2 I can write out as e power t into e power minus t. That will gives me 1. If I take the square here, that is s by 2 e power t plus e power minus t whole square you will have. This s by 2 is already there, so this is s by 4. So this will gives me s into e power t plus e power minus t upon 2 square, that is cos hyperbolic of hyperbolic square t. And this cos hyperbolic of square t we can convert into sine also. So first things you got is from this you just observe that cos hyperbolic square t, that is e power t plus e power minus t by 2 minus sine hyperbolic square is equal to 1. This is the formula, it is already there. If I substitute this value, that is cos hyperbolic of t is x by 2, this is x square by s square minus sine is y square is equal to 1. So that will give me x square minus x square by s square is equal to 1 plus y square. So the value of s, so s square will be, you will have a x square by 1 plus y square. The value of s is this, x square by 1 plus y square. So here it is x by 1 plus y square, square root of that, into cos hyperbolic square. Cos hyperbolic square is x by s square. But again, so what we'll do is we'll just write down s into x, cos hyperbolic of x is x by s. So it is x square by s square. One s is cancelled out, so it is x square by s. So finally what we got, it is z is equal to x square by s. So z square is x raised to 4 by s square. But 1 upon s square that we get, it is 1 plus x square upon x square. So this is x by 4 into 1 plus y square upon x square. 1 x square is get cancelled out. So finally you will have x square into 1 plus y square. So finally the answer is z square is equal to 1 plus y square is into x square is your surface, or I can say integral surface, which passing through a given initial line. Let us solve one more example. Question is, find the characteristic equation, or sorry, characteristic strip of the equation xp plus yq minus pq equal to 0 and obtain the equation of the integral surface through the given curve c is equal to z is equal to x by 2 and y is 0. So here is, this is the initial curve is there. The first thing is to, when we need to calculate what will be the initial strip. So the first objective is to calculate what is the initial strip. So here the initial data curve in the parametric form is x is equal to, if I write 2s, y is 0, z0 is s. If I write s, then we'll have this. Now we have to solve two equations to get the initial strip. To calculate initial strip, we have two equations. The first one is f of x0, y0, z0, p0, q0 equal to 0. That will implies, what is the function f is this? That means x0, p0, y0, q0 minus p0 minus q0. equal to 0. That will implies x0 is 2s. We'll have 2s p0, y0 is 0, so this term is not there, minus p0 q0 equal to 0. So this is the one equation we get. The second equation is dz0 by dt equal to p0 dx0 by dt, sorry, not dt, ds, plus q0 into y0 by ds. So this will implies derivative of z 0 with respect to x will gives me 1 equal to p0 dx0 by ds is 2 because it is 2s, and plus q0 into y into 0, that will gives me p0 is 1 by 2. So you have another equation, the value of p0 is you got from this equation, you will have now q0, and also 2s p0 minus p0 q0 equal to 0 we already have. A p0 is 1 by 2. If we substitute here, we get s minus q0 is equal to 0. Now s2s minus p. So the value of q0 is 2s. So this is the p0 and q0. So that's why the initial strip is only one solution. Here is a unique solution. So the unique initial strip is x0 is equal to 2s, y0 is 0, z0 is s, p0 is 1 by 2, q0 is 2s. This is the initial strip and it is a unique. Now we have to solve the characteristic equations. So the characteristic equation are dx by dt is equal to fp. Let me write what is the function f we have here. The function f is given xp plus pq, sorry, xp plus qy plus qy minus pq equal to 0. So the derivative of this with respect to p will gives me x minus q, dy by dt, that is fq, that will gives me y minus p, dx by dt will be pfp plus qfq, so that will gives me x p minus pq plus y q minus pq. So as we have already xp minus yq minus pq is 0, this will leads to minus pq. Because of this, dp by dt will be minus of fx minus pfz. Fx is p, there is no z, so that is 0, so will gives me minus p, and dq by dt will give minus fy minus qfz. The derivative of this with respect to y will gives me q, so this will be minus q. Now you just see this equation. This will implies dp by p equal to minus p, sorry, dp by p equal to minus dt. So that will gives me my ln p equal to minus t plus some constant c1. So that will gives me p equal to a e power t minus t. This will gives me dq by q equal to minus t. If you simplify in this similar manner, you will have q equal to b e power minus t. This is the two value of p and q we get. And if I use the initial conditions, then we have the value of p, this a and b also. That value we can substitute here. Then we have the value of this x and y also. So let me do that. So ultimately we need to solve this all the value of x, y, z, p and q in terms of t and s. That is our objective. So this is the equation we have. Now dx by dt equal to x minus p. That is the thing. So x minus q is there. But the value of q we got it is x minus, the value of q is b e power minus p. Now we have to solve this one. dx by dt minus x is equal to minus b e power minus p. This is the linear equation, that is dy by dq dy by dx plus py equal to q. This is a linear equation of this type. So the integrating factor in this, it is, we know it is e power integration p dx. So it is e power, here the value of p is minus 1. So it is integration of minus 1 dt. So it will be e power minus t. Here the solution is y into integrating factor equal to q into integrating factor plus some constant is there. So here the solution will be y into integrating factor is e power minus t plus integration q, the value of q is this, that is minus b e power minus t into e power minus t, integrating factor is e power minus t, dt plus some another constant, let's say c. So we will have y e power minus t is equal to minus b. The integration of e power minus 2t will be e power minus 2t upon minus 2 plus c. So the finally you will have is y equal to, this minus minus become plus, if I divide by e raised to minus t, that is b into e power minus t plus c into e power t. This is the things you got as a value of y. Not y, but here it is x. So this is not y, this is x. So this is the value of x you have. Also, we have y equation like this, and the value of p from this, we'll use that one. So also dy by dt is equal to is y minus p. The value of p we have, that is this, a e power minus t. This is the value of p is a e power minus t. This is again a linear equation as we have discussed in the previously. So this is minus y minus a power minus t. So here the integrating factor is e power pd t, but the integration t is minus 1, so that's why it is e power minus t. So the solution is y into integrating factor, that is e power minus t plus integration q value of q is minus a into e power t into e power minus t dt plus some another constant a b c d. So this will gives me minus a into t plus d. because e power t minus e power minus t will become 1 and the integration of 1 is t. So this will e power minus t is there. So the value of y finally you will have it is minus a t into e power minus t plus d. So this is the value of y. Now we'll use this initial condition to calculate this constants. We'll have p equal to a e power minus t. This is minus t. So here it is minus t. So this will be minus t. So this is wrong. This will be minus a e power minus 2t plus d. So that quantity, this will be minus plus 1. So that is e power minus t plus d e power t. This is the thing. Okay. Now initial condition, let me write the initial conditions here. That is x0 we have the value of x0 is 2s, y0 is 0, z0 is s. The value of p0 we got it is 1 by 2 and q0 it is 2s. So if I use this initial condition, so using initial condition we get 1 by 2 equal to a. We have q is equal to the value of q is b e power minus t, b e power minus t, that will gives me q is 2s. So 2s is equal to b. Then we have the value of x. The x is equal to b e power t plus c e power minus t. So that is the value of x is here. And using this value, we will have 2s is equal to b plus c. And the value of y you will have, it is from this, it is a e power minus t plus d e power minus t. So it is a e power t plus d e power minus t. So if I use this, so 0 equal to a plus d. So this will gives me a equal to minus b. And since b equal to 2s, if I substitute here, then c will be 0. So the value of c is 0. Oh, value of c is 0. No, because the value of q is at 2s by d, it is right. 2s b is 2s. If c is 0, then it will come into the something is went wrong. Let me see what is x. It is plus minus 1. That's perfect. B plus c. B plus c is 2s. Value of b is 2s. A is minus B. The value of B is minus 1 by 2. So this will gives me X is 2s e power t. C is 0. Y will gives me A is 1 by 2 e power t minus 1 by 2 e power t minus t. Now what will be the value of Z? That is this d's x by dt is equal to minus p cube. This is Z. So dz by dt is equal to minus p cube. The value of p we have is a e power p is minus p e power t. A e power minus a e power t. The value of b, or I can say y, q is b e power minus t. So this will gives me, this is minus is already there. So it gives me minus ab e power minus 2t. If I take the integration, this will gives me z equal to minus ab e power minus 2t upon 2 minus 2. Minus minus will get cancelled. It is ab e power minus 2t. The value of a and b we already will get. The b is 2s, a is 2. So that's why it is s e power minus 2t. So this is the value of z. So you have z here, x is this, and y is this. So now x will be 2s e power t, y will be 1 by 2 e power t minus e power minus t, and z will be s e power minus t. Now we need to combine all these three equations and write down in one surface, and that can be written by finding some values here. So if I have e raised to t, which is x by 2s, if I substitute that value here, that is 1 by 2 x by 2s minus e power minus t. So the reciprocal of this, that is 2s by x, and z is equal to s e power minus 2t.
सर z માં s e પાવર માઇનસ 2t by 2 નહીં.
By 2. No, see a ની value શું છે? 1 by 2. b ની value શું છે? What is the value of b? It is 2s. So 2 cancel થઈ ગયો. It is a into b. Okay,
ઓકે
this
સર.
આ 2 તો છે જ ને અહીંયા. Yeah, a2 આવશે. So it is s by 2. That s by 2 is there. Now we need to find out the equation in terms of x, y, z. How will we do that? This is x is equal to, let us do it in the next page. X is equal to 2s to power t. Y is equal to 1 by 2 e power t minus e power minus t, and z is equal to s by 2 e power minus 2t. So if I take the square here, it is x square is equal to 4 s square e power 2t, or this will gives me e power 2t is equal to e power minus 2t is equal to 2z by s. So e power 2t will gives me s by 2s, 2z. So if I do the reciprocal of this 2t upon t, the value of 2t I can put this z s upon 2z, and this is x upon 2s. This 2 is get cancelled. So we'll have s square upon xz, and so this will gives me e power t s square upon xz. This will not leads to anything. So what to do? E power t, if I got the value of only e power t we got, that we substitute here, but then it is s is there. So to eliminate s, so do the square of this one, and let me do the square of this. So this will not leads to anything. Let us do the square. So it's 4s square e power 2t. So e power 2t is equal to x square upon 4s square. So therefore x square upon 4s square is equal to s by 2z. So that will implies s cube will be x square upon 2z. S cube is x square upon 2z. And if you can substitute this value of s square, s here, so you will have cube is equal to 8 x cube e power 3t. Substitute this value, then we got this. So this will implies x cube 8 into x square by 2z e power 3t. This x cancel out. This will gives me, this will be 4 e power 3t will be xz upon 4. So e power t will be x by xz upon 1 by 3. So this is the value of e power t we got. We substitute here. So finally we will have y is equal to 1 by 2 xz by 4 raised to 1 by 3 minus xz by 4 raised to minus 1 by 3. So this is the equation in which there is no x, no t is there. So that's why this is our surface, integral surface passing through a given curve. So in that manner, you can solve as many as example. So the procedure is clear. The first things you need to establish initial strip by solving two equations. The first one is x0, y0, z0, p0, q0 equal to 0. And the second equation is this. dz by ds is equal to p0 dx0 by ds plus q0 dy0 by ds. Using solving this two equation, we need to have initial strip, that is x0 equal to something, y0, z0, p0 and q0. Once you got that one, you go to the next step to solving the sixth linear equation, that is dx by dt is equal to fp, dy by dt is equal to fq, dz by dt is equal to pfp plus qfq, dp by dt is equal to minus fx minus pfz, and dq by dt is equal to minus fx minus qfz. Solving this five equations, you will have the value of x, y, z, p and q in terms of s and t. Now ultimate goal is to eliminate this s and t from this, and using these initial conditions, you can obtain all the constants. Once you got the constant, you need to eliminate this s and t from this, and you should have the equation in terms of x, y and z. So this is a procedure to calculate an integral surface of nonlinear equation using this method. Okay, you will practice for more example, you will be able to solve certain examples. Okay, that's it for today. If you have any questions, you can ask.